We discussed about PT diagram for a pure substance in our previous video. We talked about various regions like solid, liquid, vapor and fluid region. We also talked about critical point and triple point with respect to the vapor liquid and vapor liquid equilibrium, vapor liquid solid equilibrium. So critical point is a point where is the highest temperature and pressure beyond which we cannot distinguish between vapor and liquid, and beyond that we enter into the fluid region, which has a property similar to liquid and vapor both. Triple point is a point where all the three phases, that is liquid, solid and vapor, are at equilibrium, and they are all together at equilibrium. Sometimes the region which is mentioned, which is gas, can be divided into two zones. One zone is this, other is this. This is the zone which, when increased pressure at a constant temperature, gets conversion from vapor to liquid. But if you are here, if you increase the pressure at a constant temperature, you enter into the fluid region. So if you are here and you want the fluid to get converted into the liquid, you have to either first decrease the temperature, take it below the critical point and then increase the pressure, or increase the pressure and then decrease the temperature. So this region is bifurcated into vapor and gas zone. Vapor is defined classically as a state of a fluid which, when increased in terms of pressure at a constant temperature, gets converted into liquid, which is not the case for the gaseous region, because gas region, when increased in pressure at a constant temperature, may enter into the fluid region. However, in our routine use, we interchangeably use word vapor and gas. Okay. Another aspect we talked about is that critical point is the highest temperature pressure, and for every species these critical points are different, and this is listed in the textbook Smith and Witness in one of the appendix. Every standard textbook would have the list of PC and TC associated with a particular fluid. Now we talked about the Gibbs phase rule, which is nothing but F equals to 2 minus pi into N, or 2 minus P into C, where pi refers to number of phases and N number refers to the species. Since we are talking about a pure substance, our N would be 1 because our species is 1, and hence for a pure substance, for this diagram, F is nothing but 3 minus pi. So depending upon the number of phases, our degree of freedom would be the value. So for single phase region, that is solid, liquid or vapor, our F is equal to 2 because pi will be 1. For two phase lines, which is 2 to 3, 1 to 2 or 2 to C, which are respectively fusion curve, sublimation curve and vaporization curve, our F would be 3 minus 2, making it 1. This is for two phase. This is for single phase. And for triple point, where all the three phases coexist, our F would be 0. That is, there is no degree of freedom, or another way, triple point is called as invariant. It doesn't change. Triple point for a particular species is fixed. You cannot change the triple point. So just like TC and PC, triple point is also one property or one value or a set of value of temperature and pressure for the given species. You cannot change that. However, for single phase or two phase, you can have range of pressure and temperature. I'll try to explain it now. So if we say F equal to 2 for a single phase, say for example, I decide that the pressure is here. So this is my pressure. And I say that I want to know the temperature at which this particular fluid will be in solid phase. So if I want to see that, you can just look at here. This could be the temperature, this could be the temperature, this could be the temperature, this could be the temperature. Any temperature on this line corresponds to solid phase. So what does it mean? It means that apart from pressure, I can also fix the temperature. I also have a choice. I also have a freedom to choose the temperature. So if the pressure is this, my temperature could be this, 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 anything between this to this. So any temperature which is below this temperature can get me the phase as solid phase. If I say that for that pressure I want to know the temperature for which I'll be having liquid phase, then these are the temperatures. And if I want to know the vapor phase, then these are the temperatures or the range of temperatures. So basically I can select pressure as well as temperature for a single phase region, and since I can select both, I am free to choose any value of pressure and temperature, right? I can say that I have 2 degrees of freedom. See, if I put it the other way around, say I fix the temperature, for that given temperature I can also fix the pressure values for which I have solid or vapor. Naturally, if my temperatures are on the left hand side of the fusion curve, I will not have any vapor or any liquid corresponding to that temperature. But that is something which we have for the fluid under consideration. So I can decide, like I can choose either pressure or temperature when I have a single phase, right? Now for a 2 phase, we know that F is equal to 1. What does it mean? Say I fix a pressure, right, and I say that I want to have solid and liquid equilibrium. What is the corresponding temperature? The corresponding temperature is only one, and that is this. For no other temperatures I have solid liquid equilibrium, and hence the moment I fix pressure, my temperature is fixed. I don't have any freedom for the temperature. Fine. In the same way, if I want to see vapor liquid equilibrium, for this pressure the temperature is fixed to be here. Like I cannot select the temperature, so my degree of freedom comes down to 1. Other way around, if I fix the temperature for vapor liquid equilibrium, the pressure is fixed. Temperature for solid liquid equilibrium, the pressure is fixed. So I have only 1 degree of freedom. I can choose either pressure or temperature when I talk of 2-phase system, and hence my degree of freedom becomes 1 here. And in the same line, when I have triple point, I have no choice. For triple point, pressure and temperature are fixed, and hence for a triple point F is 0, or other way around, triple point is also termed as invariant. It doesn't vary with a fluid. It doesn't, you cannot change the values of triple point for any given species. So that is what is mentioned in all this lines. You can just see this, right? So this is something which we discussed in last 2 videos as far as PT diagram is concerned. Fine. So when we meet in our next video, we will talk about a PV diagram for a pure fluid. PV diagram, only the region where vapor and liquid are coexisting. Thank you.